Hey, everybody. Okay, so today we're going to talk about stable populations. A population is a group of individuals within the same species in a particular area. That population, that group of one species, the numbers of them that an environment can sustain is very specific. And the population cannot get beyond that. So there's a stable population. That is a number of individuals in a particular area. And that's kept in check by a number of different factors called limiting factors. Limiting factors are things that keep the population from becoming too much, from becoming overpopulated. Keep in mind, the word overpopulated is not the same as overproduction. Overproduction is a healthy, normal thing that happens. It's part of evolution. You have more babies born than will survive. Some of them die, right? That's overproduction. Overpopulation is when they don't die. They just keep going because they go beyond what the environment can support sustainably. Okay, so what keeps a population from becoming overpopulated is limiting factors. And then you can see here in the cartoon, you have space is an issue. There's only so much space for these fish. And that's a limiting factor. And some of them will die if there's not enough space. We have that issue with many different organisms out in nature, not just in a fishbowl. Okay, so what are the limiting factors in general? We have food and resources. Here you can see a polar bear that has very limited resources. We have space, as I was showing you with the fish in the fishbowl. Look at these people. This is, I think, a highway outside of LA, packed, not enough space for people. Okay, it's a limiting factor, and yes, humans are subject to these limiting factors, just like other organisms. We've kind of pushed beyond them, and we're overpopulated, but they will come calling. All right, disease. Here you have a moose that has been infested with ticks carrying diseases like Lyme disease. You can see it's all, patches of it are bald and it looks pretty sickly. It's got an overinfestation of ticks, and a lot of that's due to climate change, which we'll talk about more later. Another limiting factor is predators. You can't have too many bunnies living in a field because what will happen is the foxes will eat them, right? So the foxes will keep the number of individuals in check. However many individuals a specific ecosystem can keep sustainably, that's the carrying capacity for that ecosystem, or of that ecosystem for that particular species. So if you see, sometimes you'll see in a test a graph like this. You have the number of organisms and over time. And when they're first introduced to an area, they kind of start to reproduce, and then they start really reproducing. And there's an explosion of the population. And then there's not enough space, or there's not enough food, or there's disease. Those limiting factors will make the population come down a little bit. But once it comes down, there's still some room in the environment for them. So it comes up and it kind of stabilizes in a wave. It kind of, the population will go up and down within a very narrow range, kind of like homeostasis in an individual. This is the carrying capacity in an ecosystem. There's a stable range that the population, the number of individuals that the ecosystem can sustain. Now, I want you to look for a moment at humans. So this is the graph of the human population from the year 1050 to almost 1,000 years ago. And it kind of trotted along like this. It started climbing in the 1900s. By 1960, it started to really come on up. So if you look at that, and we're like here, which part of the phase here do we see? Are we in the lag, the exponential, or have we hit our limiting factors, right? You can see right here, we're in the exponential phase, and we're coming up to a point where we won't be able to go beyond that, and our population will have to come down because the planet just cannot support so many of us. We'll talk about human population more later. And so that's carrying capacity and stable populations.